Hi guys, so here's your video to help you with today's work. It is your Tuesday daily work. It says April 28th. I will share my screen so that you can see what it looks like and then we can get started. Maybe. All right, so this is what your daily work looks like. Today we have reading, social studies, and then math at the bottom. This is in Google Classroom and in Canvas. If you are in Google Classroom, I would highly recommend watching the Canvas link videos from a couple days ago and finding your way to Canvas because it connects to your gradebook. You can see your automatic feedback. It shows all the videos. Everything is very organized. Where in Google Classroom, you can submit your work to me, but you're not provided any feedback directly like you are in Canvas. So please start to kind of make that transition to Canvas where CMS is kind of asking us to do our work. So if you're looking at today's work for reading, it has us reading 2 articles like we've been doing, providing a statement that integrates both texts, where integrate means find something they have in common and then answer a statement about it. So our first text says interview with Greg Baring Galford. If you click those blue words, it's going to open up a link. I'm going to hit make a copy. So if you have to hit make a copy, just hit the blue button and it will load up your article. So this is interview with Greg Baring Galford, a renewable energy scientist. It says greenhouse on a grand scale. In 1991, a wacky experiment began in the desert of the southern Arizona. 8 scientists would live inside a giant glass building known as the Biosphere 2, or B2. Once inside, they would be closed off from the rest of the world. Inside B2 were various working ecosystems. The dome housed a rainforest, a savanna, wetlands, and a desert, even a small ocean with a living coral reef. The scientists would use these ecosystems to grow food and provide fresh water for themselves. The B2 experiment might pave the way for sustaining life on other planets like Mars. For exactly 2 years, the scientists lived inside B2. Technical problems troubled the experiment. However, its designers and crew eventually gave up. B2 almost faded into history as just a strange experiment, but it turns out the elaborate greenhouse had a second life in store for it. Today, B2 is a giant living laboratory for the University of Arizona in which scientists can study how entire ecosystems work. In the field, scientists have very little control over things like rainfall and air temperature. But at B2, scientists can control the endless variables that determine if an ecosystem functions or fails. Scientists are using B2 to study life on our own planet and how it is changing. Greg Baring Galford is a scientist who studies renewable energies like solar and wind. The enclosed ecosystems at the University of Arizona's Biosphere 2 allow Baring Galford to better understand how renewable energies will work in the future world. Question: what types of science are happening in Biosphere 2? Most of the time we are doing environmental or climate change experiments, but we also use B2 to talk about science. It's a place where we can ask these big science questions in the eyes of the public. It's not a closed-off research lab that's hidden away. We can interact with school groups who really want a hands-on experience. Question: what could someone expect during a visit to B2? One of the great things about visiting B2 is in just a 2-hour period, you can travel from the equator to the farthest reaches of North America. You're going to go through a desert biome, then the savanna. You're going to see an ocean, then you're going to see a rainforest. Question: B2 is a closed system. What does that mean? It means we control everything coming in and out of that system. Imagine you have a really big mason jar and plop it over to contain a part of a planet under glass. We are able to control the environment to make it what we want. Question: can you give us an example? Well, if we want to know how much carbon dioxide an ecosystem will scrub out of the atmosphere, we measure how much is coming in and how much is going out. Then the difference is what the ecosystem is altered. Question: how is B2 helping us understand a changing world? Answer: the closed system and controlled environment research that we can do tells us really interesting things about our own ecosystem as we put more and more pressure on them. How resilient these ecosystems. How many times can a rainforest get hit with a drought before it collapses? Those are kinds of experiments that we do at the Biosphere. Question: what can B2 tell us about life in our future cities? We treat it as a model city. It has an industrial area, which is a residential area with rooms where people can stay when they come to do experiments. It also has a business office because it's part of the university, so we can look at different pressures on the energy grid to see when renewable energies make sense and when it doesn't. Question: what are some problems cities will face? One is an idea of an urban heat island. As we develop more and more of the built environment around us, we are essentially creating things that store the sun's energy. Why its summers seem to get hotter and drier. Question, how does B2 help us study the effects of heat island? We introduce plants into built ecosystems to reduce the heat island effect. Plants have little evaporate coolers. They cool the air with water vapor leaves, just like your skin cools when water evaporates. So how can we use this really simple concept to try to affect something like a big city? We're testing that. Question, what do you like most about working at B2? I'm able to wonder about things and chase down the answer. I always enjoyed being in biology class and wondering, how does the body work? Or how does a tree work? At Biosphere, I get to share that excitement. The Biosphere is really good at sparking enthusiasm with people who want to experience science, even if just for a few hours while on vacation. Question, why is it important to study how ecosystems function? It's about understanding our planet so that we can anticipate survival and what will be like in the next 100 years. So there's little we know about our own planet. Each new generation comes at it with a fresh perspective, and it's these fresh perspectives that really keep the science drive going. So I'm scrolling back up to the top to look at this picture. I think that this black glass pyramid is the B2 biosphere that they're speaking about, that has the different types of ecosystems within it. It's pretty cool. Going back to our daily work, I'm going to type in some of the things I can remember into this common box. So with this interview, we learned about the B2. Okay, this is the biome hemisphere. So I'm going to put hemisphere, where they are experimenting with the different ecosystems. This has a savanna, a desert, rainforest, and ocean inside. It has controlled areas, where controlled means they control how much it rains, what the temperature is, how dry it is, what plants live there, what animals live there. They control all the factors of that ecosystem. It has been used with various different scientists, and they're watching it to see if it has any effect with climate change and other things. So you can take field trips there, and they do hands-on experiments. Okay. Now moving to the next one, it says make yourself an ocean ecosystem desert. Blue link, I'm going to click it. It's going to open up today's article. Give it just a second to load up. It says make it yourself an ocean ecosystem desert. It's hard to imagine life on Earth without oceans. The air you breathe used to be an ocean breeze, and the water you drink was once a cloud over the ocean. The ocean is critical to many species of plants and animals that call the water their home. This community of organisms is called an ecosystem, making a tasty treat. Human cause climate change is warming our planet, and the oceans are feeling the heat. Plants and animals in the ocean ecosystems are sensitive to changes in the ocean's temperatures. Some organisms can adapt to the change, but others can't survive the warmer temperatures. Since so much life is dependent on these waters, it's important to keep the oceans healthy. Scientists are monitoring the temperature of the ocean with an instrument called a Moderate Resolution Imaging Soundometer, or MODIS, on NASA's Aqua satellite. The satellite measures the temperature on the top in millimeters of the ocean surface. With this activity, you can learn to make a cool, tasty version of the ocean ecosystem at home. What you need: a large clear bowl, 2 6-ounce boxes of blue gelatin dessert mix, red licorice twist, gummy fish, scissors, mint leaves, hot water, cold water, liquid measuring cup, and a spoon. How to make it. 1. Follow the directions on the box of the blue gelatin dessert mix. Pour 4 cups of hot water into the bowl with 2 packages of blue gelatin powder and stir for 2 minutes. Once the powder is dissolved, mix in 4 cups of cold water. Place the bowl in the refrigerator for approximately 45 minutes. This amount of time should allow the gelatin to become a thick liquid that is only slightly firm. 2. While the gelatin is in the refrigerator, use the scissors to cut the red licorice strips into short sections. These pieces should be only a few inches long. The licorice will represent the coral in your edible ecosystem. 3. Cut the mint into segments approximately 2 or 3 inches long. The mint leaves will represent seaweed. 4. After 45 minutes have passed, remove your gelatin from the refrigerator. It should be thicker than liquid. It should not be completely firm though. If the gelatin is still very runny, place it back into the refrigerator for 10 minutes more, then check it again. 5. Assemble your ocean ecosystem. Once the gelatin has become thick liquid, begin placing your seaweed, mint, coral, licorice, and fish, gummy fish, in the ocean of blue gelatin. Push each item into the gelatin with your finger. Be sure to place some of your fish, coral, and seaweed right next to the glass so they're easy to see. When you're done, jiggle the gelatin in a bit. This will repair the holes. 6. Place gelatin in the refrigerator for another 2 to 3 hours. This will allow the gelatin to become totally firm. 7. Admire and enjoy your tasty ocean-themed dessert. So going back to our daily work, some things that I can think about from this ecosystem dessert, it was a how to create a Jell-O dessert that's going to look like the ocean. At first, it talks about the ocean and the temperatures of the water. And then they want you to visualize what the ocean would look like. So they're asking you to create this dessert so that you can see the ocean with the different factors. So some things both of these have in common. One is a very informational text, and the next one is like a recipe and in how to create something. But the things that they have in common is that they are both talking about the ocean. And when they're both talking about the ocean, the first one is in a biohemisphere where all factors can be controlled. So they can control the temperature of the water or plants that live in their ocean. And then the second one was talking about the temperatures of the ocean. So they both talk about different temperatures of the ocean and how it's affecting the plants and animals. Now you need to come up with a statement that combines those things together. So I'm going to make my statement talk about something that the interview with Greg Barron-Galford and the ecosystem dessert have something in common, that they're wanting you to recognize that there's problems within the ocean and rising temperatures, and that it will affect plants and animals if we don't find a solution to the rising temperatures. So I have within the interview with Greg Barron-Galford and Make It Yourself. There is a common theme of oceans with rising temperatures and what they have. They're very different passages. Both want to educate the reader on how plants and animals may be affected from factor changes. Now, the only thing that's left for reading today is to answer a few comprehension questions from those two articles. So the first question says, according to the selection, Make It Yourself, an ocean ecosystem dessert, what is the main cause of climate change that is affecting our ocean's ecosystems? It says plants and animals, underwater living organisms, humans, or the weather. So I'm going to go back to our Make It Ourselves article, and I'm going to read the first part and see if I can pick up on anything. It's hard to imagine life on Earth without oceans. The air you breathe used to be an ocean breeze, and the water you drink was once a cloud over the ocean. The ocean is so critical to so many species of plants and animals that call the water their home. This community of organisms is called an ecosystem. Human caused climate change is warming our planet, and the oceans are feeling the heat. So it comes out of this sentence right here, humans are causing the climate change. So if I go back to my answers, plants and animals, underwater living organisms, humans. So I would highlight C as my answer. Second question. In an interview with Greg Baron Galford, what does the author mean by a wacky experiment in paragraph 1? So I'm going to go back to his interview. I'm going to look at paragraph 1 to kind of find context. In 1991, a wacky experiment began in the desert of southern Arizona. 8 scientists would live inside a giant glass building known as Biosphere 2 or B2. Once inside, they would be closed off from the rest of the world. So does wacky mean a physical, slightly odd, sensible, or unpopular? So those 8 people were moving into that Biosphere 2 to live there for 2 years by themselves to just be with their science experiments. I don't know that that's physical. When I think physical, I think about PE. Slightly odd. It is kind of weird that they want to leave their families and go live in this biosphere, so maybe. Is it sensible? Well, I don't necessarily think it's sensible for them to be leaving their homes to go live in another building, so probably not. And is it unpopular? Well, we don't know if they are popular or unpopular, and it doesn't tell us if they had any facts with the news or press. So I'm going to go with it slightly odd, which means it's kind of weird that they're wanting to do this. Third question. Read the following sentence from the Make It Yourself and Ocean Ecosystem Dessert. The ocean is also critical to many species of plants and animals that call the water their home. What does the word critical mean as it is used in the text? Does it mean important, minor, habitat, or comfortable? The ocean is also critical to many species. So remember, I've always said if you don't know what a word means, you can replace it with the answer and see if it makes sense. The ocean is also important to many species. That makes sense. The ocean is minor to many species. Minor means it's very small, so no. Habitat. The ocean is also habitat to many species of plants and animals that call the water their home. Maybe. Comfortable. The ocean is also comfortable. No. So it's either important or habitat. So if something's very critical, then it's more of an important thing that you need to listen to. If you've ever heard that they are in critical condition, that they are in a condition that's very important, that we need to pay attention to it and focus. And that would be your reading for today. So moving to your social studies. Social studies, we're still talking about Civil War. Now, last week, I want to point out, a lot of you did not read these directions. In the work you gave me, I could not provide feedback for because it was not on the Civil War. So if you were copying and pasting work from the American Revolution we did in reading class together, you will not get feedback from me. That's not what I'm asking. The Civil War is a completely different war and it's a different topic. So for you to get feedback, you need to watch and read these articles and actually type out your own work. Googling and copying and pasting does not count. Okay. So for social studies today, it wants us to watch this History Channel video. Then it wants us to look at this graphic map under the Underground Railroad. And then once we're done with those things, we're going to type in some key points that we learned from both of them. So I'm going to start with our channel video.
What I'm going to do in this class is use the lessons of history to apply to your daily life.
Here we go.
To understand what the Missouri Compromise is and why it's so significant in American history, we have to take it back about 200 years. Now, let me set the stage for you. The year is 1820. The U.S. is a young nation with 22 states, 11 free states in the north and 11 slave states in the south. But this balance is called into question when Missouri, a piece of land acquired from the Louisiana Purchase, wanted to be admitted into the Union as a slave state. Slavery was a highly contentious issue in the U.S. at this point. Some were pushing for the total abolition of slavery, while others looked to expand it. This issue pinned families and states against each other, creating a powder keg just waiting to explode. With tensions already high, the idea of Missouri entering as a slave state prompted heated debate in Congress and throughout the nation too. Not just about Missouri, of course, but also how slavery factored into all future states and the future of the nation. Many argued over whether Congress even had the right to spread or limit slavery in the United States at all. While Northerners argued Congress should be allowed to prohibit slavery, Southerners insisted on popular sovereignty, the idea that it should be up to the states to determine this for themselves. These sentiments sound familiar? The biggest sticking point of the debate was political power. You see, Missouri's entrance as a slave state would throw off the balance of power in Congress. So to keep things even, Congress hashed out a separate solution, a compromise of sorts. In exchange for Missouri's admission as a slave state, the Northern Territory of Maine would be admitted as a free state. This ensured equal representation between the North and the South. A second part of the compromise banned slavery throughout the remaining Louisiana Purchase territory north of latitude line 3630. But while the Missouri Compromise limited the spread of slavery, it did nothing to abolish slavery in states that already had it. So while in some ways it staved off a civil war, it was only because it just maintained the status quo. The admission of Missouri as a slave state only fanned the flames of the national debate over slavery, a fierce disagreement that wouldn't be resolved until the end of the Civil War.
So now if we move,
people in large numbers came out.
Now if we move back to your daily work, you have this graphic organizer, and it's in yellow telling you that you have to double click on the graphic organizer to be able to type in these boxes, okay? So if I double click them, it's going to open up into this like black and white checkered background so that you can type into them. So for point 1, okay, so we're talking about main idea 1. What's one thing we learned from that video? Well, I learned in 1820, the U.S. had 22 states. That's something I did not know. Point 2 of something that I learned is 11 of those states were for slavery, and the other 11 were against slavery. Point 3, if you can come up with something, the states were battling for power in Congress. So since 11 states were for slavery and 11 states were against slavery, they were equal. So they balanced out. So in Congress right now, the power was balanced. And that was on more than making decisions on slavery. Those states and those people had the same ideals. So they were voting together on issues just like we do today with different political teams. So it was important that they were trying to keep it balanced so that they could sway people their way. Point 4 was all of this Missouri Compromise came apart through the Louisiana Purchase. Once you have those done, you can hit the save and close button, and it's going to add them to your graphic organizer box. Okay, now all of your work is there and it's able to be seen easily. Now the second one that is here for us is the same type of graphic organizer, but it says key points about the Underground Railroad. The Underground Railroad is the second thing. It says examine the National Geographic map on the Underground Railroad. It is a blue link so that you can click it, and it's going to open up a website for us. The Underground Railroad map. The Underground Railroad was a network used by enslaved Black Americans to obtain their freedom in the 30 years before the Civil War. Image, Underground Railroad routes to freedom. The Underground Railroad was a network of people working to take enslaved people from the southern United States to the freedom in the northern U.S. and Canada. And this picture is showing us the red marks are similar to how they were moving people to try to get them to free states. So all of these blue states were free. They were against slavery. The gray states were slavery states. And these yellows were territories. So they had not actually become part of the United States yet. So they were almost like unmarked land. Then it says that the red arrows show the major avenues of escape. Okay, so they're showing how people were escaping. And it says the width shows how much it was used. So the wider the mark, the more it was used to get people to freedom. The skinnier the mark, the less people that used it. So now if I go back to my daily work, moving down to that graphic organizer, I'm going to double click it so that it opens up that checkered background so that we can type in 4 main ideas from that website. So one thing that I learned about the Underground Railroad is it's not an actual railroad. It was just like a secret society to help move people to freedom. This Underground Railroad was staffed by average everyday people who wanted to help make a change in the slavery laws. Point 3, the purpose of this railroad was to help free slaves. Point 4, the map shows us the difference in the free states and the slave states. The wider the arrow, the more commonly used that track was to help get people to freedom. Okay. Then I'm going to hit the save and close button so that it adds all that information to my graphic organizer. And then you're done with social studies for today. Moving to math. Math is reviewing plotting points on a coordinate grid. So it's about graphing and how to read a graph. So number 1 says to watch this review video. So I'm going to open up this video so that we can see it.
Let me introduce you to the coordinate plane. The math that reminds you of the battleship game.
Help. You came to instruct the beats. You did good, kid. 4 quadrants make a bar. Coordinate grid. First, second, third, or fourth. The y-axis runs south to north. The line that runs east to west, we call the line the x-axis. You gotta shuffle on the carpet before you climb up the stairs. You gotta shuffle on the carpet before you climb up the stairs. You gotta shuffle on the carpet before you climb up the stairs. You gotta shuffle on the carpet before you climb up the stairs.
You have a place to go when you want to know where. Directions for this map come in order pairs. The origin is where we start, where the X and Y meet. The first number order pair shows how far we need to shuffle our feet.
Take it one step at a time. The second number in the order pair shows how far we need to climb or fall. That's why.
You gotta shuffle on the carpet before you climb up the stairs. You gotta shuffle on the carpet before you climb up the stairs. You gotta shuffle on the carpet before you climb up the stairs. You gotta shuffle on the carpet before you climb up the stairs.
So moving back to our daily works, that kind of helps us with our graph. In 5th grade, we only work with the first quadrant. So that's what you're seeing down here in number 1. Both numbers are positive, but we still have the origin where they meet at 0, 0. Then you have your x-axis, which runs side to side, and your y-axis goes up and down. So just like they said in the video, you have to move over before you can go up. They said shuffle your feet before you climb up the steps. I used to say you had to go down the hallway before you could get in the elevator. Okay, whatever helps you remember, you go over and then up. So we're going to do a couple questions together to help review that graphing content that we learned at the beginning of the school year. Number 1, plotting points on a coordinate grid. In order to plot the course for the annual Girls on the Run race, school officials look at the map. See their grid below. The school officials want the race to be 2,800 yards long. Each unit on the grid represents 100 yards. Okay, so each little box is 100 yards. So even though it says 0 to 1, that would still be 0 to 100, 100 to 200, 200 to 300, because they're saying one box is equal to 100 yards. Part 1. How many units long should the race be? Remember, each unit on a grid represents 100 yards. So the first thing I want to figure out is they want to know how long we should make the race on the graph. And we want the total for the race to be 2,800. And we know one box is worth 100 yards. So for me to find the total boxes needed, I need to make groups of 100. If I'm grouping something together, I need to divide. So we need to divide 2,800 by 10. 2,800 divided by 10 equals 280. So you would need 280 boxes. Hold on, just kidding. On where 10 came from. One box is worth 100. So 2,800 divided by 100 is 28. So if I confuse you with 10, confuse myself with 10. So take the 10 out, it should be 100. So total is 2,800. One box is worth 100, and I need to divide. So 2,800 divided by 100 is 28. So the race needs to be 28 boxes long on the graph to represent the correct length. Part 2. Draw one possible solution on the grid below. The course only includes horizontal and vertical lines on the grid below. Please explain how you know the solution is 2,800 yards. Okay. So if you're struggling to figure out how to add color to these graphs, what you can do is you can always explain it out in a sentence, or you can copy and paste your work into this. Okay. So what I'm going to choose is I'm going to choose to talk about it in sentences. So I know that the whole race is going to be 28 boxes total. And it says I can only go horizontal or vertical. So I can go side to side or up and down, but you cannot do diagonals. And you can divide that up however you want to, as long as the total boxes used are 28 boxes. So I could say, in my race, you need to move 14 boxes horizontal and then 14 boxes vertical, which would end at ordered pair 14 comma 14, because I went over 14 and then I went up 14. So it kind of gives me a visualized idea of where it would be on the graph, and that it's 28 boxes long, because that was my answer for number 1. Okay. Part 3. Use coordinates to describe how the girls on the run. Where will they start? What direction will they run? Where do they change directions? Where does the race end? So this builds off of the answer I just came up with, but now it wants more directions. So instead of me saying 14 boxes horizontal and 14 boxes vertical, I need to describe what that means so that little girls would understand. So where do the girls start? The girls will start at the origin, okay? Think about where the origin is located. It's right there in the corner, and it is 0, 0. The girls will then run to the right, or if you need to use this never eat soggy waffles, if I'm moving to the right, they're moving east. Okay, so they're going to move to the right or eastward for 14 boxes, which is 1,400 yards, because that's half of the race. Then the girls will shift upward or north for the remainder of the race. And the race will end at 14:14. So now I've kind of described a visual of what their race would look like using the graph that's up here above part 1. Okay. The last part is your memory jogger for today. These are still reviewing place value, measurements, fractions, and decimals. Okay. So I will do a couple of these with you, then you will be responsible for doing the other 2. So I did A and C with you yesterday. So today I'm going to do B and D. So we'll kind of flip-flop it off. So I'm only going to do problem B and D, but you are still responsible for doing all 4 of these since they are review questions. So problem B has a lot of different choices because it's conversions. So the first part is length. It says that 7,000 meters is equal to how many kilometers? But they tell you that 1 kilometer is equal to 1,000 meters. So if 1 kilometer is 1,000 meters, 2 kilometers would be double. So that would be 2,000 meters. So then 3 kilometers would be triple. That would be 3,000 meters. If I continue on this pattern, 4 kilometers would equal 4,000 meters. 5 kilometers would equal 5,000 meters. 6 kilometers would equal 6,000 meters. And 7 kilometers, which is what we're working towards, would equal 7,000 meters. So 7,000 meters is what I started with. That's what I ended with. It is equal to 7 kilometers. So I'm highlighting 7 kilometers, so I know that is my first answer. Then I can move to number 2. Number 2 says 4 foot 5 inches is equal to how many inches? And they tell you that 1 foot is equal to 12 inches. So if 1 foot is 12 inches and I have 4 feet, that would be 12 times 4. So 12 times 4 is 48 inches. Now that's just 4 feet. We had 4 feet and 5 inches. So I'm going to do 45 inches plus the additional 5 inches that we had. 48 plus 5 is 53 inches. Since that's my answer to number 2, I'm going to make sure I highlight it so that it's easy to see. Now we can move to the next one. Now we're working with mass. 8 kilograms and 134 grams is equal to how many grams? Okay, so they've given me 8 kilograms and 134 grams. 8 kilograms and 134 grams is equal to how many grams? Where 1 kilogram is equal to 1,000 grams. So if 1 kilogram is 1,000 grams, we have 8 kilograms. So I need to do 8 times 1,000. 8 times 1,000 is 8,000 grams. Now I need to add in the additional because it was 8 kilograms plus 134 grams. So 8,000 plus 134 equals 8,134 grams as my answer. I'm going to highlight that so that it's easy to see. Moving to the next one. The next one is in pounds and ounces. 12 pounds and 4 ounces equal how many ounces? So I have 12 pounds, 4 ounces is equal to how many ounces if 1 pound is equal to 16 ounces. So if 1 pound is 16 ounces and I'm wanting to know 12, we should do 12 times 16. Okay. Well, that's kind of easy to do if you're using the calculator on your computer, but you need to show me some sort of work, okay? So I'm going to start with 12 times 10. 12 times 10 is 120. That's an easy fact we can come up with. Now I'm going to do the other 12. 12 times 6, because 10 plus 6 is 16, okay? 12 times 6 is 60. No, it's not. I don't know where I got that. 12 times 6 is 72. 60, Lord have mercy. Now I need to take those two answers and add them together. 120 plus 72. 120 plus 72 equals 192 ounces. So I'm going to highlight this so that it's easy to see. It would be my answer. Now we can move to the next one. The next one's talking about capacity. 4 liters is equal to how many milliliters? So they gave us 4 liters and we want to know how many milliliters that would be. 4 liters is equal to what in milliliters? 4 liters is equal to 1,000 milliliters, and it gave it to us in 4 liters. So 4 liters equals 1,000 milliliters, and that's one of those that's pretty easy because the answer is down in the hint. As long as you're reading through the problem, the answer was already there for you. Next one is talking about capacity, and we're dealing with gallons. 2 gallons is how many cups? So I have 2 gallons, and I want to know how many cups that is. The hint says that 1 gallon is equal to 16 cups, and I have 2 gallons, so I would need to double that. So 16 plus 16 is equal to 32 cups. 32 cups would be my answer, so I would highlight it. And the last one for problem B is time. 180 minutes is how many hours? So they gave us 180 minutes. Then they tell us that 1 hour is equal to 60 minutes. So I'm making groups of 60. So 1 hour is equal to 60 minutes. So 2 hours would be 120 minutes. 3 hours would be 180 minutes, which is what I started with in the first place. So 180 minutes is the same thing as 3 hours. I'm highlighting my answer. And now we are done with your problem B workspace. Just problem D left. Problem D. A machine in a factory cuts 4 footboards into 25 hundredths foot pieces. How many pieces are made from one 4-foot board? So the first thing I'm going to do is pull out what the question's asking. The question wants to know how many pieces I can make. If I'm making pieces, I know my answer is going to be a whole number, okay? I have a 4-foot piece of board. So I have one piece of wood that's 4 feet long, and it says the machine can cut it into 25 hundredths pieces. So I want us to go back and think about money first, because decimals are much easier when we're dealing with money for us to kind of comprehend what's going on. When I wrote 25 hundredths pieces, what does that look like as money? It looks like a quarter, right? So if I have a quarter, how many of those do I need to make $1? 1 quarter is 25 cents. 2 quarters is 50 cents. 3 quarters is 75 cents. 4 quarters is $1. So I know 4 of those pieces will equal 1. Okay, so now I've went from money back to the problem. The money just kind of helps us visualize what's going on. So 4 pieces equal 1, okay? Because I'm cutting it into quarter-size pieces. So 4 pieces make 1 whole. And my board is 4 foot long. So if 4 pieces equal 1, I need to do that 4 times. 4 times 4 is 16. So I can make 16 pieces with that 4-foot board. Now remember, you're responsible for going back to problem A, which is place value, and problem C, which is fractions, and putting in your work before you submit anything in Google Classroom or Canvas. But if you need anything, make sure you reach out. You can comment on the post, you can text or call me, and I'm available for you.